Hello guys, my name is Amit Sharma. I am the CTO of Dream11. I've been with Dream11 for around 3 years now. I um, joined them in December of 2016, and it's been a very interesting ride since then. So I thought a lot about what kind of information should I, what kind of learnings can I share with the kind of group that's coming here. And there's a lot of interesting tech challenges. Each that we've actually solved over the last few years to serve the kind of scale that we have. And if I actually started going into each of those technical challenges, that it's everything would take me like around 15 to 20 minutes to explain. So we try to do that in our tech blogs and in other forums and meetups, etc. But what I thought would be most relevant in a group like this is like how did we start, and as we scaled every year, what kind of challenges we face. Every year when you start growing rapidly the way we have grown, you'll realize that every year the kind of challenges that are facing you are very different, and you have to start thinking very differently, and things that don't matter earlier start mattering a lot more as you go on. So I thought I'll talk through the last 3 to 4 years, how we've actually progressed, and the things that we did to actually come where we are. So, just a quick introduction. I'm CTO of Dream11. Prior to this, majority of my career was actually spent in California, in the United States. Spent around 5 years working for Yahoo, and this was the time when the entire the Hadoop ecosystem was born, and the cloud was taking shape, and a lot of people started moving to the cloud. And then I moved to Netflix. Spent almost 5 years at more than 5 years at Netflix as well, and got a lot of experience around distributed systems in general, and microservices, etc. Because that's when Netflix also made the journey from monolith to microservices. So my experience typically revolves around these things, distributed systems. I spent a lot of time in the data platform team trying to build the platform for the entire Netflix verticals, because the data volumes on Netflix was in a few like petabytes. So how do you actually make sure that right from the billing to the payments to the analytics to the data science, all the teams get their data at scale, batch processing, real time, again using the distributed systems concepts. Open source, I'm a very big proponent of open source. Um Contributed as well and used a lot. I try to use open source wherever I can. Our tech stack today is also a combination of pure play open source, some open source technologies which are offered as managed services by some vendors like Amazon and Instacluster, etc. And of course some proprietary tools which we have to use sometimes, and we feel that it doesn't, but my priority would always be open source whenever I have a chance, of course, to save cost as well. AWS. So Netflix was the poster child for Amazon Web Services. That helped them like prove the model that you can wear. Netflix is 100% in the cloud, so that showed us like if Netflix can do it at their scale, then it's definitely possible and economical at the same time. So until you reach a scale of companies like maybe Google, Facebook, where it makes a lot more sense for them to start investing in their own infrastructure. So a lot of experience around AWS and have seen it evolve a lot. We have a very great relationship with them as well, so that helps, of course. Uh, okay, the slides messed up. I don't know why. So I will need to project from this. Can you move this laptop inside? Because this is not PowerPoint. Just a minute, guys. Yeah, because no, so this laptop doesn't have PowerPoint, right?
No, no.
But
Why are you doing?
yes, that this will give me my notes now, I guess. There are, so the notes are all gone. That's fine. Okay, so sorry for the interruption. Let's continue. Um, So just a slide that talks about how from 2015 to 2019 how the user base, the registered user base for Dream11 has grown. So we're on just around a million users we hit in 2015, and since then the rapid rise. So unlike other platforms, what happens for us is our traffic is very seasonal in nature. So considering that we're heavily involved in cricket, so during the IPL time of the year, what happens is a lot of interest comes into the game, and so from IPL to IPL, we see a surge in the number of users that come to our platform, and also the traffic that we actually get onto our servers. To give you some idea about how what kind of scale challenges we have some numbers. But before that, just a quick mean for people who don't know what fantasy sports is all about, right? So this is how you basically play a fantasy sport. You select a real world match of a certain sport, be it cricket, football, kabaddi, basketball, and hockey is what we support today. And between the two teams, you actually create a choosing the players from the two teams. You create a team of your own with using a certain constraints, certain combination, right? And once the match actually starts and those players start performing, based on their performance, you start getting points. Now there's a total number of points that your team is accumulating, and then you compete with other users and their teams. So there are a lot of leaderboards around. So there are small contests which are like head to head, which is to member, and then there are large contests as well, which are lakhs of people that are there in a single contest. Some contests are free, some contests are paid, where you pay and you actually become a part of this contest. So that's how you play fantasy sports. So back in 2016, we were very excited. We hit a peak traffic of 1200 TPS. On a request per second, 1200 requests per second on servers. It was like a very healthy number. A lot of people that I actually interview or reach out to people, like, once they hit like 1000 RPS, they get very excited because it's a pretty solid number. And so then we started preparing for the next IPL. And in the next IPL, we went from 1200 to 12,000. So this is like a 10x growth that we actually received, and then it's a good problem to have, right? And we were like kind of preparing for it, and we are like, okay, how do we do this? So we had to build an infrastructure around that. And then come 2018, we went from 12,000 to 48,000. So this is the trend that like we become. So this is getting becoming old at this point. Like we kind of knew this is what is going to happen, and so we started thinking long term. Again and again we started thinking, how do we build, because we had to constantly work on our systems to actually scale. So we used to hit the peak in IPL final, and then it used to stay around there or slightly lower till next IPL, and the sudden jump. And the latest 2019 IPL, we went from 48,000 to 400,000 TPS. So this is the kind of problem that we have to solve at Dream11, right? Because what happens is a huge game would come in, like a Mumbai Indians versus the Chennai Super Kings, and then so much interest comes into the game. Everyone wants to play, and everyone flocks to the system exactly at the same time. Certain other constraints also happen because of that. So this was the traffic that how we need to build. Some per second, per second. Read, write, of course, combined majority of them read. Some statistics actually that I wanted to talk about, right? So we hit a 2.7 million user concurrency on our platform this last April. This was the peak that we actually hit. 40 million RPM at edge services that we actually did. So read traffic is one thing, right? You can do all kinds of replication, sharding, etc. to actually help with that. But we also do transactions, right? Our system is like very transaction heavy as well. So when I say transactions, what does that mean? People are trying to create and update a team. So that's an update to the database. People are trying to join contests, right? Especially close to the match deadline, which is just when the match actually starts. A lot of people are trying to join the contest. So that's the contest join. The people trying to when they're trying to join the contest, they need to add money to their balance. So they're trying to deposit money. So that's a transaction. So we had 4,800 contest joins per second at peak, 2,400 deposits per second, uh, team edits, right? The moment the toss is done and people get to know who's playing, who's not playing, they rush to the system to edit their teams. So we hit 15,500 team edits per second. The largest contest that we've served is around some more than 40 lakh people in a single contest have joined. And we recently actually won a Guinness Book of World. We created a record of Guinness Book of World record for the largest number of contest joins in a single match. And that number was like, I don't even bother anymore. It's more than a crore, right? And we actually achieved all of this with a tech team size of less than 100 people, just around 100 people. And the distributed system backend, the scale that was actually provided with the backend was built by a team of 25 backend engineers. This is the reality for us at Dream11. This is what we've been doing for the last few years. Um, an interesting tidbit about our system is the traffic is not linear, right? So what happens is like you have a lot of interest and people are watching the game, and some events happen. Like for example, there's a toss. Whenever a toss happens, the teams come out, people flock to the system. Match deadline happens, people start. I mean, a lot of people join the contest over the maybe the last few days, But when the match starts, everyone will come to the system and see what's happening. And that's the first time when you can actually go and see the teams of other people that you're playing against. Before match deadline, the teams are locked. You can only see your own team. As soon as match deadline happens, all the contests that you've joined, you can actually go and check your opponent's team at that point. Then during the game, interesting events happen, right? Some you have picked, say, Virat Kohli or Dhoni as your captain, and he goes crazy. He starts playing amazing, and you get a lot of points. So he's a very popular player. A lot of people would obviously select him in this team, in their teams. So what happens is when he starts playing, everybody would come to the system again. So because of these external events, it has a direct correlation to our systems. So we'll have like a certain traffic at like a certain, and this is a kind of a slightly older. Maybe I couldn't find a decent graph, but slightly older. But the patterns remains the same. So we'll have a few million RPM, and within like less than a minute, we'll go from like 2-3 million to like 10 million or more. And that's why things like one of the best features of AWS is auto scaling doesn't work for us, because by the time Amazon realizes that we need more capacity, our users have come and gone. So we have to actually provision for peak. We have to build systems to actually ensure that, okay, even if there is a surge, we can handle it. Now that adds cost. Of course, we have to figure out patterns how to avoid that. So we do a lot of work around that. But this is again a challenge, right? So how did we build this? So it all didn't start. So this patterns, everything, the year-on-year growth is obviously there, but back in the day when everything started, this wasn't the case, right? So I thought I'd quickly walk through the journey that we've had and how we actually built a system to handle something like this. So in 2013 to 2016, this is actually even prior to my time. This is where the team actually built the system, and just like any other system, just like Charpy's like two boxes, right? Everything starts with a monolith, right? And you're trying to figure out. You don't care about scale. You don't care about anything else. You're trying to figure out like product viability, like how product market fit. What am I building? I mean, what do my users really, really want? You want fast iterations. You don't want any, like a person would probably have a system running on their own laptop instead of a production server to whatever it takes, right? You have an outage, you just go in and you just log into the system and you fix it right there. So you focus on that. And then suddenly you get that, you put that inflection point where you're starting to get some scale, but you don't have the expertise, you don't have the manpower, you don't have the people. What do? You find silver bullets, you find a solution out there that you can buy to give you scale. So the first attempt that for which we did that was we tried to migrate to Amazon Aurora. So Aurora is a RDS that Amazon provides, and it works slightly different than a typical MySQL setup, right? And so some of the characteristics of Aurora actually kind of gave us a bootstrap or a jump start to horizontal scalability. And what was that? So this, right? So in majority of the MySQL, if you see the slave databases, right, especially when the throughput in the master increases, the replica lag starts going up. So one beautiful thing about Amazon Aurora is that they guarantee you that your replica lag will never be more than 20 milliseconds. And they have the capability of adding like 1 to 15 slaves in this way. Read replicas is what they call. So what this gives you is you can put all your write traffic to the master, all your read traffic to the slaves, and you get like read after write consistency. So mature. So there are very, very tiny cases where you're probably like 20 milliseconds is also too much for you, but in 99% of the cases that's not a problem. So we replaced our main database with this, and we started relying on this for our horizontal scalability. They have an abstraction built in front of the read replicas as well. So you have a reader endpoint. You don't care about what's happening behind. You just specify the reader endpoint to connect, and it does the load balancing itself. Some other advantages, we obviously didn't have a DevOps at all at this point. So at any point of time, you want to scale up, scale down. At runtime, you can actually change instances. You spin up a read replica of a slightly bigger size, and then you promote it to the master, and the master becomes a slave. So the DevOps capabilities are built in. If there is any time there's a problem, any system goes, if master gets overloaded, there's an automatic failover, and within like seconds, a new master comes up. So all these capabilities basically said that, okay, maybe we just go with Aurora right now. Of course, Aurora was very new. We had our own share of issues with it. We worked very closely with the team. The first migrations were not smooth at all, but somehow we made it work, and it actually worked for us, right? So all this happened, and then just before 2017 IPL, that was the first time we said that, okay, we expect like significant traffic this time, and that's where we had the 10x jump in the number, right, in the traffic as well. So we're like, how do we prepare for it? We had a very, very small team. So 8 backend engineers at that time, right, to handle the entire system. So we said let's prioritize and handle and look at the things that we think will get hit the hardest. That not all sections of your system are going to be hit with the same scale when you get traffic. Certain things will get more, and certain things like payments will never be at the same scale of your front end system, for example. So we identified 2 points, right? We said everyone who comes to Dream11, whether they play or not, whether they join a contest or not, will load the first page and they go to the match that's the most popular and they get a list of all the contests. Now that API will be hit the most. So that's our fetch contest. These are how our contest page looks, right? We have like hundreds and hundreds of contests, like not at the same time, but then as and when contests keep getting filling in, we add more contests, right? We've gone up to more than 1 million contests in a single game. So homepage is the matches, right? And then once you go inside the page, or single match, you have contests. Now those contests are dynamic in nature because every second the number of spots left is changing, right? So that content is slightly like you can cache some part of it, but some part is very very dynamic in nature. You have to show the users how many spots are because otherwise it becomes a trust issue, right? So what happens is you have like 100,000 and suddenly what happened, right? So you have to constantly show the number of people who are joining and whom are you playing against. Even though you don't know their teams, you want to show them who they joining against and stuff. So this is the contest page, and then the leaderboard. Of course, everyone who joins the match and a contest, once the match starts, they have to go to the leaderboard and they see their rankings during the game. So obviously, right throughout the game, you constantly your leaderboard APIs will continuously get hammered. So for fetch contests, what we did was, so our older system used to be like everyone used to go to the database and pretty much come back with the exact same data and go out, right? So we just used a very simple pattern. At that time, it was we took us time to think, but now in hindsight, it's interesting how the first time you face a problem, you take a few days to solve it, and when you solve it, you're like, yeah, it was kind of obvious, wasn't it? Right? So what we did was we ran a cron, like multiple crons every 5 seconds, and then all of them went to the database and populated a cache layer, and then we started serving the data from the cached layer to everyone. So that kind of gave us like the respite that we needed from this, right? So this is a solution that we used for this. For our leaderboard, we realized, we looked at the numbers, we did some math, like our older system was actually a MySQL query that calculated the leaderboard for all the contests within like a few seconds, right? And then we said this probably might not scale. So let's start moving towards a data engineering NoSQL based solution. So we introduced Spark and Cassandra for the first time in our system. So this is how a leaderboard looks, right? It shows you the points that you're at, it shows your rank, it shows your own rank, and it shows you the top 10 people and maybe like top 100 people, right? It shows your movement in ranks, and these ranks are calculated every minute, right? So we try to like keep updating every minute during the game. This is the engaging feature of our app, right? So this constant need of like, so we have like thousands and thousands of people joining thousands and thousands of contests, and for every contest we have to update it, provide multiple views like your own data, your comparison, and back in the day we also had a desktop which had like 4 different views as well. So it's a very complicated setup. So we wrote a blog post about it as well. We codenamed Project Aryabhatta, right? So how we actually all the contest joins happened in the MySQL in the Aurora database. Once all that happened and the match deadline hit, we used a data pipeline to transfer data to S3. Then we used to read data from S3 using a Spark cluster, do the calculations, create the initial views in Cassandra, multiple views, and then every minute the Spark job used to run and then constantly update this leaderboard. This was our first experience in creating a data engineering solution in Dream11, and we said, okay, let's introduce it in the IPL. And while our primary MySQL-based solution is running, we slowly start transitioning to this system. But guess what? IPL starts the first day, the legacy solution stops working. The query is taking 8 minutes to run because MySQL is like that, right? I mean, over a period of time, it will be fine, and suddenly once the data increases, it just goes crazy. And we're like, okay, screw this. We have to make this leaderboard solution work. And we did manage to scale it up, and we did manage to run it successfully. But these are some of the scary times, right? When you're like, things don't go according to plan. So we were rushed into this. We finished this maybe like 2-3 days before the IPL, and we went live, and we actually served the entire IPL using this architecture. So we solved these two problems during that. Now, every IPL we introduce new systems, we get a lot of learnings, and then we work on those learnings, and then we prepare for the next IPL. So And these learnings are very generic. You probably, as you start scaling your systems, you'll also start maybe hit similar problems, and these learning might help you. Like for example, capacity planning. We did our work. We thought that okay, this is the kind of servers, this is what we need, and we were all prepared. And we're sitting in a war room, the first match of the IPL, and we worked on it for months, and we were all like sitting there nervous. And as soon as the traffic hit, we had an outage. It's like the most disappointing thing having that you worked on most in the first match itself, like, and your entire and like team, your product team is all panicking. Oh my god, right? Because what do we do? And then we looked at it and we looked at our numbers and said, oh, we're short of servers. So we grossly underestimated the amount of servers that we would need to kind of handle the traffic that we need. So capacity planning is a very important thing. We've gotten better at it over a period of time, but at that point we didn't know. So what did we do? We just blindly threw servers in every possible place that we could and hope for the best, and it worked. Right? Because that was the problem at that time, right? Scale was the issue, the capacity was the issue. So we actually did that. I already spoke about how the leaderboard, the legacy solution didn't work. So so we started the IPL. There was an outage. Then everything worked fine, and our first day traffic and our last IPL final traffic like this, even during the IPL. So we were comfortable for the first couple of weeks. Then in the middle of the IPL, we again we have an outage, and we tried to debug a small outage, but we couldn't figure out what actually happened. And then I said we maybe just a blip in the system. And then 2 days later, there was another outage, and they're like, oh, there's something serious, right? And this is the time when we actually spent a lot of time debugging, figured out, and we weren't able to figure. And then eventually, we ended up on a stat in CloudWatch where we saw that for Elastic Cache, which is like Redis managed service by Amazon, we saw that the network out bytes graph kept going like this, and then it became straight. So like, oh, so we are actually hitting the limit of network out bytes. The pipe, we filled the pipe completely for that instance type. So we reached out to Amazon, we confirmed this theory with this, and they said yes. So again, the solution was easy, right? Upscale. So we went to so with every instance type upscale, they actually, so back in the day, I think right now, I think majority of the lines are 10 Gbps, but at that time it was like 1 Gbps, 2, 4, and it wasn't very clear also. The documentation didn't say it very, very clearly, but we upscaled and we figured out. So this was again the couple of small outages. So nothing major, but couple of small outages that we had during the IPL in that time. Our monolith, our Aurora, right, works fine for scale, but at the same time, we had so many aggregate queries running on it, so many different things happening that if you do a show process list, you'll probably lose your mind, right? And we were like hammering Aurora like anything. So for some reason, this is a problem we worked with Amazon for 2 years and we couldn't actually solve till we carved out everything from it. Uh, the freeable memory of the master used to keep dropping, 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 and ideally in an ideal world it drops and after a certain time it recovers, right? But for us, it never recovered. It kept going down, 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 and then it became like less than 10 GB. Aurora used to panic like, oh, something is wrong. It did a failover, and the slave became master and went to the top memory again started falling. So we said that if this failover event happens during a game, it can really disrupt our users' experience. So I said, let's not do that. So every night we did a manual failover. Every night we had to reboot, and during the later part of the IPL, we had to reboot like multiple times a day, choosing the right times that okay, this is what we do to keep the show running. So we said, okay, so we have to make sure that we prioritize removing these aggregate queries from our main transactional database that is actually serving our traffic, right? And these aggregate queries were not like analytical queries that we could just stop. These are actually powering some parts of our UI in real time as well. So we couldn't actually just stop them. Um the third outage or small outage during the IPL that we hit was because of DNS, right? So we started getting so much scale that when the servers used to get and they had to talk to other services, the DNS lookup started choking. So we introduced an NSCD cache on all of our EC2 servers where actually it caches the DNS lookup bits for some time, and we introduced a solution. But again, this was learning. This is not something that we expected. And we weren't that great with performance testing and load testing at that point of time. So this is again something that we actually did, and we introduced a system and we got over this hurt. So the IPL was a little rocky. So all in all, majority of the time it was pretty smooth, but we had a few outages here and there, and every time we learned from it. But we were very happy with what we would achieve because we've seen the 10x growth that we got in traffic, right? No, internal within AWS itself. Yes. So of course the key was like we knew that a monolith would not survive to the next IPL, so we have to move to the microservices. There's a lot of literature. I mean, even I had some experience and we've read. Everyone knew that we have to do microservices, but trust me, it's not easy. You know, when you have built from scratch, you can build beautiful microservices, but you don't have the time and resources. But when you have an existing system that is like so much so convoluted, like how do you even start? Like figuring out the strategy itself to how to get started is so difficult. So we said that what do we do? Should we take a complicated piece of our architecture and carve it out? Or should we actually gain some experience in the microservices architecture by carving a small, like maybe communication service or a notification service? Like, what's the point, right? And for us, as soon as IPL gets over in June, the clock is ticking, right? We have just 9 months. We don't have the luxury of, you know, if we don't hit, we always know we have an external deadline always every year. So we said maybe not, right? The data model is like very, very tightly coupled. And because of the nature of our business, where people are actually joining a contest by paying money, you know, you're in a typical content website or e-commerce and all, things are okay. But when it comes to like, I'm joining a contest and if I win, I'll win like lakhs of rupees, like people are very sensitive about the money. So we have to give a very strong, consistent experience, right? So you, if basically due to the limitations of cap theorem, eventual consistency is not a very good option for you. Eventually, we realized that we had to loosen consistency a little bit, but our goal was always to give as strong a consistent performance as possible. Now, once you go to microservices, I mean, people who've done it know that you have to move to eventual consistency. So, how do you solve this problem? Your transactions break, right? So everything happens in a single transaction. You're deducting money, you're doing this, you're giving promotions. It's very easy, right? The moment you split into microservices, your transactions are happening across the board. How do you do two-phase commits or other patterns? I'll touch base on this again later in my slide, but this was again something that we were thinking. So we said, okay, you know what? Let's pick the most complex piece. Let's do the most difficult thing first. If you solve it, we know that other things will be easy. So that's the strategy that we took. May not be the best for you, maybe something else works for you, but this is what we did, right? So contest microservice, which was the most important thing, we actually said let's start working on that. But we said that okay, but we have a monolith and all the clients are talking to it, and then suddenly we'll do all kinds of things. Like how do we actually manage this? Right? We need an orchestration layer first that sits ahead, that understands what is actually happening behind the scenes. How do we do that? Helps us do the transitions when we introduce the microservices. Has some business logic for routing. You know, we need to build that first before we can actually start breaking things in the background. So we've created an edge layer for ourselves, right? We call it the coordinator, right? And what the job was purely okay. Everything goes to the coordinator, and there it decides what am I supposed to do next. So in parallel, right? We obviously once you get more traffic, more users, more money, of course, right? And you want to scale as a company, you do other things as well to figure out how do we become more mature, more efficient, and move faster. So we hired our first DevOps, and he started working on our Jenkins pipeline to help us with deployments. When I joined, my engineers used to like broadcast and like log into 30 machines at the same time and do git pull and restart servers, and the deployments used to take hours. Then we started working on our automated deployments. We started saying we have to start doing automation for testing as well. One of the mistakes that we actually did was, so when we had an ever-changing product, right, the design was constantly changing, because again we were still in early stages, right? We were getting traction from users, but we wanted to give a better user experience. We have to improve conversions all the time, and so we realized that we started with UI testing first, UI automation, and that was a mistake. In hindsight, we actually redid our UI automation like 2 3 times, and every time that became stale before we could use it. So if I had to do it all over again, I would actually start from the back end and start figuring out the APIs first, so that gives you some breathing space to the QA to actually start moving forward, right? So that is something that we would have done. I don't know if you know about the Spotify squad model, right? There's those pods of like cross functional teams that they put together and they give them a focus area. So we got inspired by that and we created dream teams, which is a combination of the UX, UI, product manager, back end, front end, and give them areas of focus and say you guys operate on this. You're a decentralized team, because we didn't want a lot of top down decision making. We wanted a bottoms up culture, right? Bottom up culture. So we basically said that these dream teams are going to be responsible for certain areas. They decide what to do, and then we just let them do it and we get out of the way. So we created dream teams. We were on Scrum, didn't do that well. Moved to Kanban mode, then moved to Scrum back again. And we said that okay, now we have so many users, we're getting so much data, we have to start investing in data. because it's going to become one of our competitive advantages as we go forward, collecting so much data about our users, trying to understand their behavior and give them a good user experience. So we actually started forming a analytics team, a data science team, a data engineering team. When I say team, it's like one person at this point, right? But we started at least, right? We said this is our direction, this is what we want to do. So they started doing their work behind the scenes as well. Again, then it became a cycle now. So 2016, 2017, 2018, again we are in that period where like, okay, IPL is here again, we have to prepare for it. So the good thing was we were able to carve out our contest service. Yeah, this is the most nervous time for us. But the adrenaline rush that you get when you're sitting in the war room and you see the numbers and like skyrocketing is something else. Absolutely, you have to be there to feel it. Um, Contest service was done, coordinator was also ready, the routing happened, we started moving some matches to the new service, and coordinator decided that where should I go for this match, that logic started happening. And then we said what next, it was like 6 weeks to go to IPL. We said that we're not ready yet, right? We need to like speed up, so we picked up two smaller services per se, and we said let's carve them out to give this particular area of like creating a team, joining a contest, a little bit of isolation, right? And we didn't even touch our leaderboard at this point because the leaderboard was anyways like match deadline ke baad we moved the data separately and the entire leaderboard ran separately. So we didn't do much there. We were confident that Cassandra would scale and Spark would scale. We were fine. So we carved out three more services, and in each of them we took a different strategy. Like our authentication service. From our monolith where all the user registrations etc happen and login etc happen, we just created a data pipeline to a different database and put application servers in front of it, and it used to just authenticate based on the token and get the data in. Like we were like, okay, fine, this is what we'll do here. For team, it was completely isolated, right? Because every match has its own team. It has nothing to do with historical data. So we were able to do a fresh start with team service. So we created its own database and created a very clean microservice there. So there was a different strategy for that service. And in tour is like the metadata for us. So every single call needs to understand what match, who's playing, where is it being playing, what is the time, what are the flags, what is the squads. All this data is very, very important. It's basically needed almost in every API call that we have, at least at this point. So here we said that let's do one thing. Again, we went back to our cron crashing strategy. We started running multiple crons and we created a data model in Redis basically, and we said all the traffic. So Redis became the backbone for our tour service basically. So each service you have to look at it and you have to figure out how, if I had to carve it out, you don't have to do it right the first time. You get one level of separation, then over a period of time you keep adding to it, then you start cutting up the database and in its own service you create a reverse data pipelines if you have to do it as well. That's something that we did later on when we were doing carving out tour completely, right? So you have to analyze each and every service, and of course from our previous experience we knew that load testing and capacity planning is very, very important. So we invested a lot of time in trying to understand traffic patterns from last year, what actually happened, and how much capacity would we need. And because we were able to mimic the production slightly better than earlier, we obviously were better prepared when it comes to capacity for this IPL. So we had a very decently smooth IPL, right? We had a 99% 99 uptime, which really is much more smoother than earlier. We were much better prepared with our alerting and monitoring because we spent a lot of time building New Relic dashboards. Because what happens is the moment you start building more and more services and your system starts to slow down, you don't know what's happening. Like monitoring becomes a nightmare. So it's important to invest in a dashboard that helps you pinpoint very, very fast that which part of your entire system is actually creating the trouble. So we built this, it helped us a lot. We had latencies of all our main services and a summary so that we can quickly track where the issue is and go in and actually solve these problems. So we had a much more smoother and successful IPL, and at this point, we had started getting a lot of confidence that yeah, we kind of understand scalable systems. What are the challenges? The performance testing, NoSQL databases, segregation, microservices. We were beginning to get the feel of it, getting confident. Again, there were learnings. We start, as I said, at every stage when you scale as a company, you'll start hitting different challenges. So now what happened was instead of scale challenges at R and alone, we hit some scale challenges in AWS. So ELBs, right, elastic load balancers that we all use, right, they're supposed to like obviously become like handle our traffic and keep scaling up as usual, but they have a limit, they have a capacity. Our traffic was surging so much so fast that Amazon ELBs were not able to expand and handle that. So we had to actually work with them and pre-warm the ELBs for our traffic. We had to tell them this is the kind of traffic that we are expecting, and they actually started. So, and we didn't know this, right? The ELBs couldn't handle our traffic, and we saw issues in production, and that's when we discovered this, and we reached out to them, and they said, yeah, this is a limitation, and then they actually worked with us, and then we started informing them from before and that what kind of numbers do we expect, and they were prepared for us. We did a load test, but load tests can never 100% simulate your production traffic. Right? And we're talking about like millions of users, like 2.7 million concurrency at one particular time, 40 million RPM. Like, how do you even simulate that? We use JMeter to actually hit, with like 100 servers, etc. But the actual behavior is slightly different. So we were able to handle a lot of RPM in our load environment, but in production, we started hitting issues in our edge layer. So what we identified was that the CPU and all was fine, memory was fine, but because of the number of connections and synchronous like requests from the clients, we were running out of sockets. So what we needed was we were acting at like C4 2XL or C4 4XL edge layer. What we did was we downscaled the servers and we doubled the number, so that this, because we had room for we had resources available, right, for CPU and memory, but what we didn't have was number of connections, because the 65,000 sockets or whatever, right? So those are the limits that we started actually hitting. So that settings, like some settings in Nginx to make sure that it is configured currently, some U limit settings, I mean, I don't remember all those details, but yeah, so a lot of operational work needed to actually solve these kind of issues. CloudFront, uh, we had our beautiful dashboard and we're sitting in our war room and everything is smooth from our end, right? And we're like, amazing, 99% of time. And every now and then someone would come from the office and say, I got this crash, I got this crash. And then over a period of time, we started realizing that if like 100 people in this office, like if 10 people are getting it every day, something is off. It's statistically significant. Something is really, really off. So what we started digging deeper, we found that the entry point for traffic into a system was CloudFront. So even before the traffic, we were only monitoring the traffic that reached our edge layers. But what about, but there was like around 10% of the traffic that was getting a 5xx error from the CloudFront layer itself. And the reason for that again was that some of the pop locations that Amazon had, there was some cache they put in the middle and they were not able to handle our scale. So again, we reached out to them. They reached out to the CloudFront team. This is where like we had a good relationship with them, right? So they immediately moved people around. At first, it was like, is it ELB? Is it CloudFront? They couldn't figure out, and eventually they figured out it was a CloudFront issue. So they reached out their teams and they started giving us some. I don't know what they actually did, but they did something, and it solved this problem for us. So from our learning, CloudFront actually gives you ways to set up alarms. So they give you graphs for fire, but we never thought of monitoring CloudFront because we thought that of course CloudFront can handle our scale. So make sure end to end of your systems have monitoring and alerting set up. And after at this point, like we set up like 5xx alerts alarms from CloudFront as well. So anytime, even there is a 1% problem with CloudFront which happens from time to time, we actually get an alert and we can immediately start working on it. Another issue that we hit was, again, byproduct of hitting scale is hotkeys, right? So caches work beautifully, Redis works beautifully. In Elastic Cache, you can have one single master, and you have sharding, but the number of replicas that you can have for one particular master is 5. The limit is 5. I think recently it's increased, but at that point it was 5. So we started hitting that some keys were so hot that then we were maxing out the capacity of all the slaves itself. So then there are multiple options there, right? Either you cache that locally into the system somehow, or if the data doesn't change that much, the first thing that we did was we hard coded it. Fastest solution, because the data didn't change for like months, right? We said for now, let's just move on, let's just hard code deploy and then we'll figure it out. Other option is you actually create multiple versions of these keys and rotate, make them rotate and put them on different cluster shards as well. So those are some of the solutions, but you'll definitely, at some point, you would definitely hit a hotkey problem into your systems as you scale up. And the problem with moving fast and having a small team and serving so many users is that you'll make mistakes. You'll introduce bugs which can be really, really critical, right? And it's not the best thing to happen to you, but it will happen, right? So we introduced a bug in our team service where we had like a limit of 100 credits to create a team, and you do a bug. There were some teams, it's very few, but some teams created with 101, 102 credits because of a small bug in the team service that we had carved out. So then we had to like, now this becomes a trust issue, right? We cannot let this be, competition has to be very, very fair. So we immediately, the good thing was we had alerts set up. So we identified this. We reached out to users. We told them this was the problem. We were very transparent. We called them and we got it corrected. We told them to recreate their teams. But these things will happen as you move fast and you're trying to scale as fast as we were trying to scale. So as I said, by end of 2018 IPL last year, we were like, okay, we got on a handle of things, right? I'm like, and we cannot always be in this constant thing of like building for this IPL. But we have to start thinking like, because we are barely hitting 80 million registered users, and we actually don't expect this growth to slow down anytime in the near future. And considering that we eventually go maybe international, our user growth is going to keep growing, and the interest in a game is also going to keep growing. So we have to start investing in systems that actually are almost infinitely scalable, and they work for the next like 5 years, not just one IPL. And this was the first time, because of the stability of our systems and the work that we have done, and slightly bigger team size at this point. It's all relative, right? And then we said, okay, let's start doing some R&D and D and spend some time, take a breather, take 2 months off, and not be in that rat race all the time, operations all the time, and think. We spent like 2 3 months figuring out what should be our architecture, what do we need to do, starting investing time in that. We said that okay, we have to add features to our game because this competition coming up, a lot of other people, we need to give more engagement to our users. We have to build features, but at the same time we need to build platform components so that the people who are building features move fast, right? So a lot of stuff can be done in a centralized horizontal layer. We need to start investing time in that, and we have to continue to scale our systems. So all these three things have to happen in parallel. So how do we structure the entire thing? We started looking at databases which we didn't have earlier. It's like, I don't know how many of you use DB. It's a completely in-memory database that does things slightly different from how traditional MySQL database does. We introduced Aerospike as one of other NoSQL system. We moved our um, tour service and then team service to actually Aerospike. And we said, okay, our monolith to microservices journey happening. We have to complete everything by March, right? Before next IPL, we should be completely 100% microservices driven architecture. There should be no monolith left. And like a lot of our plans, of course, it didn't happen. Uh, so remember the data team, as I said, the 1% data team. So in the background, constantly what happening is that team was growing and starting to do a lot of interesting work, right? So we started doing solving some really interesting problems. The first thing was, as I said, we have some pre-generated template. So template is like what kind of an entry fee, how many people will play a contest, what is the price distribution. So we had certain templates and we had those auto-generating contests every time they filled up. But then there's some other category of contests that based on the demand, based on how many people are there, how many contests are being filled, what kind of match it is. There's an operations team that was constantly creating this. And this operations team was later, initially it was just one person, our CPO, was creating all the contests, right? And then we said, okay, we cannot rely on on manually creating all these contests. So we needed to build some kind of machine learning to understand what kind of contests are created historically, what's working, and make it more efficient. So we created a contest generation engine, and we at this point we moved like again we generate like millions of contests in a single game at runtime, right? So basically we moved completely to 100% of our contests generated completely automatically in an automated fashion. Not only we generate contests based on the templates that have been created in the past, now in the next step we've actually start figuring out what kind of contest should we create. Why do we need to limit ourselves to what has already happened? Maybe it's time to actually tweak the contest structure itself. So we created a template generation engine itself, and that constantly churns on new templates, and we constantly experiment with those and figure out what is working, what is not working in production. We, just like any other business, we give discounts, we give promotions, we give bonuses to people. Like, but what is the criteria? So we wanted science behind that as well. We didn't want like a single team, a product team to like do some data crunching, but we wanted a much more scientific way. So this is something that's not done, but again we're investing heavily in how do we identify what promotions should be given to what user at what point of time. uh, the moment there are promotions and offers, etc., there is people trying to take advantage of it, right? So we strongly believe in fair play in our entire system. So we have a lot of rules and checks and balances around it. So we constantly invest in a fair play violation detection system. So that's again, the data science team is working on that as well to identify which users are trying to game the system, how to work with them, find them and then communicate with them and tell them what's allowed, what's not allowed, etc. So a lot of interesting stuff beginning to churn out at this stage from the data team as well, you know. And you'll be surprised that every little once you have so many different teams, every team does small thing, but when you put them all together, the aggregate effect is like a lot. Um, so 6 weeks before our IPL 2019, the backend team is sitting and they're like much more comfortable. They're like, okay, we're getting ready. We know what we're doing. We are prepared much better this time. We don't have to stress during IPL. And suddenly, the business takes a massive decision. So we said that, okay, earlier, the match deadline for any match used to be 1 hour before the match. We said, let's move it to match time, you know, and that from a backend team's perspective changes things drastically, right? Because the entire user behavior changes, right? So people are like, okay, so they don't have any more information, or not really a lot more information about the team 1 hour before than they do a day earlier. So people would join contests at their own pace, create teams, and then be done with it, right? And all of them would come flocking to the system after match deadline to actually see the leaderboard. But now the entire pattern changes. What happens is they want to wait till the last minute to get the most information about the game. Now they can get that because the toss is happening. People are talking about pitch conditions, which players are injured, which players are not injured. Do they want to invest in where the game is happening? Or some of the games, people like popular games, people know the players, but in some of the smaller games and leagues, people don't even know the players. But now because they have time up till the match to make a decision, their interest level rises. So things that were never a problem, like think about it, right? So maybe um, you have lakhs and lakhs of teams created, and then uh, maybe the toss happens 10 minutes before the deadline. So we expect almost the entire user base who's playing in that game to come in and change their team. Scale was never an issue in the team service, right? So the max scale that we had actually served in team service before was 300 TPS. And business came and said that let's do some back of the envelope calculation, worst case scenario. Why don't you change this system that has served 300 TPS and max to serve 50,000? And this is like 6 weeks before IPL. And then and contest join rate, that there's a lot of contest join before by deadline, but in this way, that number itself will increase as well. So instead of that 3x target, why don't you do like 6 to 7x? And this is like 6, yeah, and they were like, this is just crazy. But we took it up, right? We actually took it up. We probably didn't have elegant solutions to all these problems, but we did whatever we could to actually solve it, right? So, and now what happens is during earlier stages when you're scaling as a company, we are like, don't worry about anything, just scale the system, and if it works, we'll be in operations mode during IPL. We'll not do anything else. Then people start getting more confidence and greedy at the same time, right? And they're like, okay, business, this is great, scale is great, but we want to start adding new features during the IPL where we are acquiring like 20 million users, new users every IPL. We want to showcase like really really nice features to them. So make a system that works at scale, and you can actually disrupt it by adding new features, testing them, and at the same time make sure that the business continues. So that again changes the ballgame completely. So just like wanted to spend like 5 minutes, like these are some of the design patterns or like solutions that we came to solve some of the problems that we had, right? So the easiest thing is sharding, right? I mean, sharding is like one of the oldest methods that you can do, right? So for team service, so every user, so anything that's user centric, right? User data, and where it doesn't have to do anything with each other can be sharded based on the user level. So we said, okay, for this, let's not try to. We don't have time. It's only 6 weeks. Let's try take the most simple possible method. Do around like divide the user base with whatever basic algorithm in 3 parts, and 3 different databases, and we did a sharding basically. Worked very well for us, right? And we kind of figured that we can add more shards when operationally. Not, my engineers are not pleased about sharding. They don't think it's an elegant solution, but for me it works fine. So I'm like very happy. Pops up methods. So our leaderboard is recalculated every minute. So, but when we're talking about like more than like a few million contests across millions of users, it's very important for us to show a very consistent view to them, right? Because if two people are sitting next to each other, we cannot have one person who's seeing like a score that's ahead. Although at the end of the game everything gets added, but people don't have that. Users don't have that patience, so they start questioning you, right? So we said, okay, we only flip it atomically once the entire leaderboard is generated at the next event. So we started putting an event entry for every leaderboard calculation that we had, and then we said like, but how do we communicate to our fleet of servers, right? And at the same time, we didn't want all the traffic that came for the leaderboard to go to Cassandra. So we wanted to put a cache. So what we said was we can actually put a local cache layer with that. Every time a new event is generated, that local leaderboard is get cached, because one of our contests is the mega contest where majority of our users join. Now that data, the first page of the data doesn't change between two iterations, between two events. So we have the ability to cache it locally on our servers. But how do we know that the data is changed? That's why we use Redis pops up, right? So Redis is a system of pops up where it actually publicly send a message to Redis, and it sends a message, and then everyone knows that it's time to actually update the event. So we introduced that as one of the patterns. Memoization. When it comes to metadata, right, it's very important that, as I said, tour service is one service that we have that has a lot of metadata information about, a lot of contextual information that a lot of our calls use. So what ended up happening is, as we scaled more and more features, more and more services, the scale on tour service kept increasing. Now there are multiple ways to solve this problem. One is that when your metadata changes, you push that metadata change to all your services, right? That's one method. But in our case, what happens is, with a service like tour, so we call it the match, the round lock time. Right? It's the time at which the match closes and you cannot join. Now that data is very sensitive. It can be changed. We cannot afford that data not being propagated to one particular system and showing a wrong information to the user. So those kind of challenges exist. So we didn't go with that approach, at least for now. We're still working on it. And then what happened was, we saw that tour service started hitting 30 million, 40 million, 50 million RPM. Like, this is like, even if you could horizontally scale and serve it, it's very inefficient, right? It costs a lot. Now, how do we solve this problem? So we introduced memoization. So in memoization, what we realized was the tour information across user requests, multiple users are requesting, is common. So it lets you group a bunch of these requests together. You'll get like whatever, there are a lot of parameters you can control that in a particular amount of time. You group these parameters together, and it just sends one request ahead to the end system, to the service, gets the data, and all the requests get the information and we get it back. So once we introduce this into our system, our throughput on that metadata service dropped by 75%. Now it made a significant change into our system. And this is again something that we played with, it worked, and then it worked so beautifully that we actually started introducing it a lot of other places. So our edge layers, right, where all the traffic comes in, we group things and we said, okay, we'll go and we get data back. QC. One of the things that we actually did by the introduction of VoltDB, which is an in-memory database, it's not a great database. It's a great database for writes, but when it comes to reading and the kind of use cases that we have, and if you put read and write at the same time, it was creating a lot of issues for us. And remember, we were preparing a system for 10,000 joins per second. And one of the challenges in contest joins is that there is a counter that maintains how many people have joined that contest. So in a typical MySQL world, what that basically means is you go and make a join entry and you update the counter. So everything gets serialized behind that lock. So now we started hitting that throughput limit in MySQL where it couldn't scale, it couldn't give us a throughput. For us, it didn't go more than 1500, 2000 in our tests, right? And that definitely didn't work for us. So we had to move to a different system. So we introduced VoltDB for that. And VoltDB allows you write to it, at the same time it throws an event into a Kafka out of the box, and you read that, and we are actually populating MySQL, and at the same time some other views, basically putting into S3, etc. So all our writes are happening here, all our reads are happening here, it's working fine. But again, remember I said that our system has to be very consistent in nature. Now this breaks that, right? You have source of truth is here, and then you have a pipeline, and any pipeline, no matter how much ever you say, there will be missed events. Now there's a lot of quality checks that need to be put into this. So one of the things that we did was, okay, we'll write it here, but we'll do a dual write also. Now if we do a dual write and we build a pipeline, that event that comes in, maybe with a combination of these we'll have some guarantees. We put some interesting patterns, right? So one of the patterns that we did was, we did a write, and we, in the dual write, and we put a flag there. And when the actual event arrived, we changed the flag so that we could identify which event didn't propagate here. Then at the same time, what we also did was, we ran scripts in real time and in batch processing, combining data from multiple services and trying to have various levels of QC to identify which data is missing. But it's not an easy problem to solve. We did solve it for this IPL, but going forward, we're investing heavily because a lot of our systems are now falling into this. We want to move towards a read write kind of a bit of a system. So we are actually constantly investing in what kind of quality checks we can actually put to solve this problem. Saga. So this is the latest entries. This is a see now 2019 is a time where me as a CTO, my team has grown to 100 people. My data team is like 20 people. DevOps is 15. QA is 20. That I know less and less about my system. Right? There was a time where you could ask me anything about my system, that I would like, this is how it happens, this is how it works, this is what. But now I don't know. We are exploring Vertex, we're exploring Akka, we are actually using design patterns like Saga, which I've never used in the past, and I just get to hear about it, right? So Saga is basically a way to remember the problem that I said, that of distributed transactions. So you have a contest join, right? So what you do is you get a request of a contest join, then you go to the wallet service and you do a deduction of the money, then you come back and you make a contest join. But what happens in between them? What if one happens the other? Then this has to send a request saying refund. So this was the pattern that we used. But now we're building a central framework for such things. So what happens is all the local transactions are grouped together, and the system itself, the centralized system, actually does one at a time. And if anything fails in the chain, it knows how to repeat or go back and revert the earlier transactions, or try it again if it's an idempotent. So from developers point of view, once the centralized system is ready, all you need to do is do the specification of these are the things, these are the transactions that I want to do, this is the behavior, these are idempotent, these are not idempotent, this is how you revert it, and one central system would constantly keep doing this for you. So this is again a design pattern that we've introduced. This solves a lot of our problems that into our system. So this is just a few examples, right? The point is that once you start hitting scale, you'll constantly be faced with tough challenges, and you'll be constantly be like out of the box thinking and looking at the patterns, some existing patterns and maybe new patterns, to solve these problems. Performance testing, right? Performance testing is great. We actually got a lot of experience into it and we became much better. Like, we could predict, we could simulate, we could do a lot more, but it's not easy, right? One of the biggest challenges when it comes to performance testing is data. How do we generate? So now I'm talking about a point where we have like more than 50 microservices. Now, how do you gather and generate seed data that aligns across all these services so that when you send a request that goes through multiple services and comes back, it makes sense? So generating that data is a huge problem. You can never simulate production equally, like how much ever you try. We've done in the past. We've come much closer now. I think close enough for us because majority of our tests are running fine now, but it's a challenge. Cost. Remember, your production costs are the highest in any environment, but in an environment like ours, we are preparing for 4x of the traffic that we get in production. That means our load environments have to scale a lot more than our production, and different people are running different load tests at different times. So if the costs can balloon like anything, so we completely use spot instances in our load environment to get the cost down. But it's very important to build automation, right? That scales up, scales down, and fast. Because what the last thing that you want is a lean team that you're ready with your feature and you're about to load test, and it takes like 6 hours for the infra to set up and come up for you to do the test. As soon as you start running the test, you're like, oh, I need 3 hours to fix it. What do you do with that infra? If you scale it down, again, it'll take 6 hours to come up. If you don't scale it down, then you're paying for it. So that automation and tooling is very important to actually solve this problem, and that's something that we're heavily investing in. So we want to reduce the time. So at this point, even with our 50 plus microservices, we can spin up an entire production like environment, maybe 3 to 4x bigger than production, in less than 30 minutes, just with pure tooling. Everything comes up, starts talking to each other, you have an endpoint and you just hit it, bam. And spinning up the load environment is one thing, and cost and optimization. But once you start doing your load tests, you don't get the desired result. Then what? If you don't have eyes into the system, you don't know what to optimize. So the monitoring and instrumentation in a load environment to tell you exactly where your bottlenecks are, which service, which part of the service, what is the issue? Is it CPU? Is it memory? Is it database? Is it slowing? What is the latency? What is the latency? So many different things. If you don't have that, you'll just constantly, you have a huge environment that's set up, you're just constantly like breaking your head trying to identify where your like meter is running, your cost is running, and it just doesn't help. So you have to make sure that you have to constantly work on that. So basically, architecture wise, this is where we are. Uh, these are the major services that we've actually carved out. We're still working on payments, wallet, and reference about the monolith. Other than there are very very small legacy stuff that will probably still be left. Things that don't actually belong anywhere, right? This is pretty much our architecture. We have verification, team, tool, user, loyalty, all the services. Technology stack wise, we pretty much, I mean, we use like maybe like 40 to, as a CTO, I want to limit the number of components that we use. But as developers, they want to use everything on earth, especially if it's like nice and shiny and new. They're like, we should use it. So it's a balance, right? So I give them the freedom of what they want. But at the same time, we have a very strong processes around how do we make this. We make data driven decisions. You can do POCs, come back with research, like talk to your peers about why we need the system, do some initial tests, and then you progress. This is what we have currently. We're adding Akka to it. We have Vertex as a framework that we already some of our services are using. Uh, this is a representation of our stack end to end, right? This is again, I want to go back and like 100 people team. This is what we manage and run at scale. So we have all the apps that hit. So we introduced. So actually, a couple of years back, we introduced GraphQL as a layer in front of our coordinator. Yeah, with the orchestration layer that actually gave REST APIs for everything, we actually created GraphQL. With GraphQL, the added advantage is that it puts a schema, right? It puts a schema on the data in your APIs, so the clients don't have to actually constantly call the raw APIs, get back, and your iOS and your Android and your web and your desktop clients don't have to do that business logic. All that business logic can be shifted to GraphQL, and the clients just ask for what they need. So going to a component architecture becomes a lot more easier in it, and it gives you a lot of power and flexibility. And then from the server side also, because everything is coming to GraphQL, it gives you an opportunity to do a lot of optimizations, which you wouldn't be able to do if you're serving raw APIs. And if once the clients are hooked onto that schema-based way of asking for data, uh, behind the scenes you can change your APIs completely. Right? You don't backwards compatibility becomes a lot more easier, especially when it comes to your service-oriented architecture. So that helps a lot. Again, the client layer, it's Elasticsearch, Fluentd, Kibana. So, so we have the coordinator. Then again, we have services, all the databases that we use, all the services. We have a data lake in S3. We have Redshift as our warehouse. We actually moved to Google Analytics completely for our analytics, and then we realized it couldn't scale. It was getting too expensive for us. So we start Google Analytics. Right. So Google Analytics, the front page that you actually see, once your user concurrency goes more than 100,000, the page doesn't load. The real-time dashboard, the behind the scenes, you'll get everything, but it's not meant. We and our concurrency touches like 1-2 million. So I mean, even now, building it in house. Yeah. So basically, we moved the entire. It's still in progress. No, it couldn't. We actually worked with them, and they said they're working on it, but working on it. So we couldn't rely on that. And at this point, to be very honest, it was getting very expensive. So we did some math around if we took it in house, how much would it cost versus. Yeah, so BigQuery, etc. It's like every time you run a, so if you run a bad query that scans so much data, it just suddenly gives you like $100 bill, right? Yeah. Yeah, right. Correct. Absolutely. Yeah. So we couldn't give that power and from our and Dream11 is a very open company, right? I mean, people are free to get any data that they want. So we didn't want to do that. So we are building it ourselves basically, and we have some experience around it. So we're making a lot of progress. Of course, technology-wise, Node.js is where we primarily started. Then we introduced Java, and Scala is the next thing that we're actually working as we move towards the Akka framework. But this is our very nice impressive. So even monitoring, right? We have New Relic, we have a self-managed EFK. So I forgot to mention. So we used to use a company called as Logly, which is a managed service for ELK. And when our IPOs, and we used to rely on Logly for alerting as well. So the logs-based alerts we used to set. When IPO started, our traffic hit, our Logly ELK stack used to lag by 8 hours. It did not work at all. We tried whatever and they just couldn't scale for us. So we said, okay, this is another thing that we have to take in house. So our EFK stack now handles all our 400 TPS in real time. It stays current even today. And we've tested it for far beyond as well. So we've reached to a point where almost everything that we do, we have to slowly start taking it in house and optimize. Things like GA, Google Analytics, will give you a lot of things, like 1,000 things. You may need five, right? But those five have to work like really, really well. So the advantage of taking it in house is obviously that you just optimize it for your exact use case. Uh, What's next? In any high throughput system, I think I don't know if people have read the reactive manifesto, resilience, responsive, elastic, message driven. Even we are in a synchronous mode of communication right now. All our services are talking using HTTP. We want to move towards message driven. So we've kind of started exploring the actor model using Akka to actually do this. And our favorite service, the most complex, we always target that first contest service. We are actually moving it to Akka and try to see how it actually works. Standardization is the key, right? 50 services, maybe 100 tomorrow, a small team. Every time someone has to work on a different service, it goes crazy, right? You have to have frameworks. Vortex is one framework we also chose, and we build a lot of our service on that. We are exploring Akka and see how it goes, and we'll probably have, maybe we cannot have one. We realize that we try to say only one, but it doesn't work. A lot of our services don't need all this complication. So we have a Node.js based framework, we have Vortex, and we have maybe Akka, and then we'll figure out how it goes, and we'll maybe zero down to 2 to 3 frameworks for like maybe say 100 services. But it's very, very important. Frameworks also help you avoid time in redoing the same thing, right? Be it like connecting to cache, connecting to DB, analytics. There's so much thing that you can build in the framework. The new devs just come up and running, they write business logic, and boom, they're like productive. Platform components, we want to do it. We've never been able to do it because we're constantly busy trying to carve out our monolith to services. Containerization, we've moved to Dockers and environments completely for, again, like our staging. We also want to move production. Again, we don't have the confidence yet. We'll slowly move there. My DevOps team is also not as big as I would like them to be, just like my other teams. Um, we have a lot of deployment infrastructure, but one thing that we actually couldn't, we kind of lagged a little, was testing automation. So this year we've taken it upon us that like before IPL at least, we'll spend heavily, because once we solve the continuous testing, we want to move to that check into deploy phase and move very fast. Because remember those dream teams that I talked about? The only way they can move fast is you give that environment where they can deploy, fail fast, roll back, have automation, so they don't need to constantly do regressions again and again. The QoS don't, and that slows people down. So speed is the key for us right now, right? And we are growing, we have grown up, we've gained a lot of intelligence, we've gained a lot of experience, but we want to move fast. Even at this scale, we want to move fast. That's where all of this will help us. Data Hive is just the code name for our project, for our analytics, in-house analytics, basically a centralized expressway to move data fast. So these are the things that we are actually moving on fast. So we've kind of figured that fantasy sports, there are a lot of features that we are adding, but we've got so much learnings. And I'm like, why fantasy sports is probably not the only thing that we want to do, right? We want to start moving out. We want to start doing other stuff. And that's where we like very excited to launch FanCode, right? Basically, FanCode is our next app that we've actually created, right? It's unlike a typical fantasy sports system. It's more of a content app that we want to create. So things that you can do in FanCode, we're actually building as a republic of sports, basically. 0% ads, 100% sports. We don't believe in ads as well. We don't have any ads, even though we have like such high user base, concurrency. We don't have a single ad on our platform. We are a transaction based system. We have the same philosophy here. We have streaming deals with a lot of providers. We started live streaming 2 3 months back. We are like signing up with a lot of people with a lot of content that we think will be relevant to a lot of people. Fastest live scores, we are trying to do our best, and we internal benchmarks we think we beat CricBuzz as well for live scores. So cricket live scores, go to FanCode if you're using CricBuzz today. uh, Sports news videos, expert analysis to help complement. So we have a fantasy sports ecosystem, right? And to play fantasy sports, it's a game of skill. So a lot of people invest time in researching. So we know what they want. So we want to amalgamate all that together in FanCode and help them the best information available for them to create those fantasy teams on Dream11. That's where the fantasy tips and tricks and expert analysis and stats, like we'll provide that. I mean, this is just the beginning, right? Again, now Dream11 went through the entire product market fit to scale, and we said, why not do it again? So we're finding more and more opportunities to do that, and we're very excited about FanCode for that purpose. So that's all I have today. We like hope that all this helps you when you actually scale your companies, and I'll take questions now. KPS, you want to come as well?
What's your tech stack for mobile?
Mobile web.
Yeah.
Uh, the apps are native basically. So iOS and Android for Dream11 is native, but for fan code we've actually done React Native completely. And our web is like there's no framework we use. It's completely in-house framework that we use. We build a PWA basically, but it's in-house. No frameworks used there.
For the native, are you using any frameworks? Android.
No.
Your problem statements involves high scalability. I mean,
Yeah.
it keeps on running. How do you arrive at while doing the capacity planning? It keeps on increasing exponentially.
Yeah, it's a constant learning experience, right? Basically, so we have business projections, right? So we go by that. We're like, how many users did we have last year? What do we expect this year? And built on that, we add buffer, right? Basically, we end up putting a number that we know we won't hit. To be very honest, right? Uh, we are very aggressive when it comes to capacity planning. We would say, and even till this point, we were like. We would probably over subscribe the over capacity is the method that we use so far, but I think we're adding science to that as well, so we're getting better at predictions and like scaling up and down our infrastructure as well, but generally we just over capacity is what we do.
You faced this with me, I forgot to ask one thing. How about, see, you're dealing with credit cards and customers' money. So, what is the security related?
So we are a PCI level one company, like, and as I said, right, we don't store cards in our system, but cards pass through us, and that's like so. We have basically we ensure that none of the endpoints are directly exposed, and we have all your clam and other security things run, and we ensure that all we have a lot of alerting mechanisms in terms of any anomalies. In terms
Also do the team separation, because the dev teams don't access sensitive
Yeah,
data.
so no, dev teams don't have access more than not even to the staging system. Dev teams just max have access to dev. Even dev, I think we are restricting nowadays. Not everybody has even access to dev. So in the longer term, we want to go something like a separate account for teams to play around with, not really work with, have access to our systems. So even dev, the problem is not just security. It's also about people going and changing things sometimes and then it's screwing up the overall build process. Basically, access restrictions, and we have key rotation policies, and always even if you want to log in into our production system, it's a very restricted set of users. But then for the restricted users, we have a jump server with SSH and password, again two-factor. And, all our servers are MFA. We don't have anything without MFA. Basic and difference in depth types, where we for things like, for example, you had a uh, heart bleed, right? Where you could get things can work for those type of things, right? If you have a ELB in the front, always you ensure that you have something else in the front, right? Reduce the scope of what that particular edge instance can do. It reduces your exposure to that to whatever hacks can happen. And so always having something in the front, and which is with a very restricted access and what it can be done and everything else, including having simple things like ensuring that your the user at which you run your server, if you're using not Lambda or something, that you're using a EC2 instance, you don't use it run it in the EC2 user group or the pseudo user group. You have a separate user for that with a very restricted access, no write access to the machine, just read access, very restricted, even with that level, right? It just helps. So just basic security things, and having restricted access to every time, every access, every role, everything, right? So we specifically there are a lot of services, right? It's easy to give global role access roles to all access to all S3 buckets or all things. We don't do that. We ask which this service what specific S3 buckets it accesses, what or which SQS queues that it accesses, which DynamoDB tables it accesses, and then we specify what specific actions it is going to be performing on that, and specify the role access roles for that particular service. It's not global. So any just common trying to reduce that. Uh, Still, we are including additional as you said, right? The team size becomes bigger. It's tough to keep track of which team has added which new jar or which new open source library into it. So we are planning to see if we can reduce the chances of remote code vulnerability by maybe even using Java level security uh, thing, so that that particular code can execute only very specific set of operations even within the JVM itself. Just basically trying to box it to to allow only for that. Sandboxing. Because as the team size becomes bigger, it's just not only around uh, security. It's also about availability. And so sometimes you write code which is just done by downloading a lot of data or doing something a lot of things in memory. So microservice just helps us in that, so that it boxes things, any issues that happens at that box level, and you just layer it, especially in the edge. You just reduce the number of options that can do, and it's just yeah.
Oh, I have a question. This is regarding Kubernetes, right?
Yeah.
Why is what kind of challenges you are facing rolling out to production? Both of you.
See, it is see, one, ours is a billing system. Okay, so we want to be up always. If you are down for a minute, customers lose a lot of data. It's 24 by 7. So for us to take any new tech into production, we had to be completely comfortable that we'll be able to debug things. For example, your EKS role, right, audit role level, pod level roles, it's just now released. So if you want, so we heavily use access roles. Yeah, it's possible to install a third party thing and then do it. Just that, there's just so many layers to it, and so much understanding that has to be done for us to, if there's any debugging thing. And you just want to see if you are comfortable with it in the pre-dev environment, in the testing environment, understand the whole thing. It is just that production is at, at that level. We just cannot tell the customers like saying that no, we went down because we just know how to debug it.
Nothing to do with
It's
any
not
security
EKS, right? I mean,
concerns.
to answer your question, it's not EKS, right? It's anything in production, anything new that you try. Once you're when you're in initial stages, you can experiment very easily. But one of the things that you actually lose out on once you become a bigger company, you have like a lot of mission critical stuff running. That the process of adopting something new and taking it live becomes longer. So it's a comfort level that you develop. Your DevOps teams are like for the first time they're deploying it, and for Dream11 there's additional challenge of like very very high scale. How do we do capacity planning when it comes to moving to a completely containerization model? How would that work? How fast can we scale up? So we need to have a lot of experience, right? So we started with dev, then we started with staging, then we're given the QA. So right now, other than the production and obviously the load, which is exact clone of production, everything is in Docker, right? Basically. And now, once we learn and get better, we're hitting issues, right? We're hitting small challenges, nothing major. But once we develop that expertise, that's when we start moving some of our service to production. But I think it'll take a while for us to have the enough confidence and expertise to move our mission critical services to Kubernetes completely.
Then it's also, as you said, right, there's also a concept of tooling. There'll be tooling that doesn't understand, so you need to build the tooling also, right? to be able to revert things quickly. So you have different toolings, and you can't move all the services at the same time to it. You need to have, if you, so there's a lot of what do you call, a lot of and there is always this, you always have a customer pressure, product pressure, and we would like to move to communities, but just that I have to also be comfortable in the sense of, in the sense, it's, so basically it's a phased release. We would be there. So for example, the FE servers is what uh, it's even in staging and everything else is, it's what it is in production. I just said, uh, and then next amount thing is we have auditing. Uh, we have to be compliant. So you need to AWS, when we started with PCI, our auditors, we took a lot of time for us to convince a lot of things about saying that, hey, this is, I can't handle this with AWS, and explaining things, and even now to make them understand that I can auto scale, right, for critical services. IPs, every IP they say has to be scanned. Also, how do you auto scale that? So you also need auditors who understand the AWS as well. And if you bring in K10, and then just it takes a lot of
Basically, it's not there yet.
not that, it's just that it is there, but I'm just saying, we are not there yet. I would say in production level we are not there. We need to understand what auditors will say, because when they audit things, do they understand it? Will they ask for that some will they ask that at each pod level you should install what do you call, climb AV, really that takes 100% of the CPU when it runs? We don't know, so we're just taking it slow.
Yeah, I had one question for you. One of the problems with the mobile heavy system is that mobiles are offline download, and the APIs that are there in the mobile, right, may not be compatible with the. You have to make changes on the server side, right? And then the mobiles are not probably updated. Different multi-million users are downloading the mobile, and some people will be running older version of your application. They may not have upgraded it, and you'll have compatibility issues with your backend APIs, and you have to release it, and you need to force them to update all of that.
Correct.
How do you handle all of this?
It's all planned, right? So majority of the times what happens is it's very rare that we do backwards incompatible changes, right? That's you have to, especially with the Android world. With the iOS, it's not that of an issue, right? With iOS, anytime you release something within like 10 days or so, it's 90% adoption happens. But with Android, it's very very fragmented. So so we try our best to do backwards compatible stuff, and then of course once in a while we do an optional update where we try to push you more and more users to the latest versions of the app, and maybe 2-3 times a year or maybe up to 4 times we try to think of a best time for it, best strategy. But I would say on an average, like I had a conversation with product and we wanted to target like once a quarter we do a force update, and then we stop supporting all versions. But even in force update, what happens is what you do is you wait for the organic adoption to happen. So the people that you're actually affecting is a very very small percentage, like single digit, that actually get affected, because the force update is not a good experience for users, right? So force update is basically that if they don't update, they cannot use the app. So they get to a point that if you want to continue using it, like you have to update the app, otherwise you'll not be able to play.
So it just wakes up and checks.
Correct.
If it is not
Absolutely. So we have a mechanism where,
within that part of that.
yes, so we actually build in, right? So we have the capability where we'll send an optional update to users. So every time they open the app, they initialize the app, they'll get a message saying like a new version is available, what's new, update. They can skip it. That's optional update and they continue playing. But in some cases, we also have like you have to upgrade to play. If not, then you just the app just shuts down.
That's what it is.
Yeah,
Architecture you have used present
correct. Leaderboard, basically, right? So what we realized was our there were multiple views that we wanted to serve, and our leaderboard is very interesting because it's so a lot of systems are optimized for writes, a lot of systems are optimized for reads, right? Our leaderboard use case is that in every minute we're crunching like few gigs of data, thousands, millions of contests, users, and updating the DB. And at the same time, we're serving like millions of reads per minute as well. So Cassandra is actually optimized for writes, but its read throughput, especially if you do pointed reads, is like amazing. So what we did was we use Spark, and we crunch the data, we create all the views that we need, and we keep it we make it completely denormalized basically, right? And so it's just a lookup for Cassandra, and we populate multiple views of the same data in Cassandra, and we stitch it all together using that event ID that I mentioned. Because with multiple views, the challenge is like how do you make sure that you get the data for the same event, right? So we use the event ID to stitch data across those multiple views, and Cassandra gives us a very high throughput rate.
So which product
Hel-
started works or developed for your business?
None. So Cassandra, we actually started with our own open source, which is on EC2 basically, and then we have a managed service provider called InstaCluster that actually is now helping us with Cassandra. And rest of the stuff is all AWS. We don't use Spark is all open source. You don't use Hortonworks or Cloudera.
So my question is to Amit. If you can share more about the read-write segregation, real-time read-write segregation, especially in the point of contests and joins, it will be more helpful.
Yeah, so actually, when I was preparing the slide, I thought I'll spend like 5 10 minutes talking about this. But then I thought that if I go deep into that, I have to first give context, try to explain to you. So, I mean, I think if you want, we can catch up after the presentation. But quickly, I'll summarize, right? But the point is, so we have a contest user relation table where an insert happens every time a contest is joined. And as I said, there is a counter table, right, that keeps track of. We cannot overfill the contest because that becomes a trust issue for us. So we don't allow that. So we have a contest master table. Then for every contest join, there is a request that goes to the wallet to do a deduction. So there's an entry there that maps against this transaction what that actually happened. So and then plus there is the right system that I spoke about. And then when there is a another thing that happens once you join a contest. So you can create up to 6 teams in Dream11 right now. So you can join a contest with a team, and then after some time you're like, I don't want to join this contest with team one. I want to join it with team three. So you can do a switch team. So that goes to that again contest user relation and then changes the team ID, right? So all these updates are happening in this source of truth data system that you have. Now we've created a data pipeline and we are actually serving the reads from a different system. So we every time we try to correlate the data between these, right, we were missing certain points. So what we realized was our strategy needs to be multi-pronged, right? So for example, suppose we have a two-member contest, right? So there'll be an entry into the contest master table whose counter should be 2, and there'll be 2 entries in contest user relation. Now in a worst case scenario, and it has actually happened in production, in a worst case scenario, those 2 events of contest joins wouldn't flow to the read system, and that one and those so contest master, you create a contest, so that's one entry, so that sends an event. Then when the first time one entry in the contest user relationship happens, you update the counter, so that's another event, so that should actually fire an event. And then number 2, there should be 3 events for contest master and 2 events for contest. So these 5 events have to flow. Now if all of these 5 events are missing, then that means the read system doesn't even know that a contest like this exists. That is our first problem to solve. But what we do know is that you cannot join a contest till that time you don't deduct money. So what we do is we actually get all the contest IDs from our wallet where the contest joins have happened, and we go cross check with all the contests that have been joined on this side and see if any contest itself is missing. Now if it is, we sync that. Now suppose we realize that at least contests have shown up. Now we have a copy of contest joins here and the contest master table here. Now these two have to be in sync, right? So I cannot have 2 entries here whereas the contest master says there are 3 entries, for example. So if that happens, then I know that some entry in the contest is missing. Then I try to identify those. I don't want to get into the details of that, but then we identify what is missing. And the third is the entries could match. So contest master says 3 entries, there are 3 entries. But what if the switch team event didn't flow? Then the user has actually joined with the team 3, but I would show him that he joined with the team 1, which is the problem. So what does that mean? That means I have to show that the event that has gone, the switch team event is actually flown. Now how do I guarantee that? That's where a dual write system comes into the picture. So when a switch team is happening, we do a write first into the read system that the switch team request has come. See, again the challenge here is you write it here, but your switch team may fail, and before you can revert it, again you have to assume the moment you're writing to two systems, it's a problem, right? So you have a dual write, and then you wait for the event with the flag that I talked about. Now that again, so I'm saying the QC strategy is multi-pronged, right? You have to understand your use case, go in depth, identify what all places, under what scenarios things can be missing, and then you pick one by one and you put it all together. Plus time, right? It's great if I give you, oh, you have a day to do QC, but that doesn't work, right? Absolutely, absolutely. There's a lot of tooling, a lot of infrastructure, monitoring, scripting. There's go behind the scenes. It's a very complex system, and we're talking about like huge volumes of data. And the databases itself that you use would have limitation. Like VoltDB, for example, it's great at the throughput. It's in memory. It's great. It's partitioned. It has its own system, but it doesn't let you pull out more than 50 MB of data in a single query. It has a limitation. So I cannot be like, give me all the data for a round, especially because it's a production system. It doesn't let me do that. How do I work around these things? So that's where the challenge of QC lies.
Amit, my question is to you. Like, from where exactly or how exactly you guys get the real-time data, like so score updates and all? Because, like, you have an in-house team to maintain that, or you are interacting with some other systems to get the data.
Sure. It's a combination. We do both, right? So we get our feeds from a lot of, so we have tie-ups with a few feed providers, right? Opta, Sports Interactive, and a few others for different sports. So sometimes it's the association itself that gives us a feed. So we get that feed, real-time feed data for all the scores. And in certain cases, we also have an operations team, sports operations team that actually has all the panels and all built up. And they can also go to a manual mode to actually put the scoring and done as well. So we do both.
Because sometimes your application is more dependent on their data actually, because they are the ones who are sending the data to real-time data to you. Because sometimes in Dream11 also we get a lag, like right now the score is on second over and we get to see the score at 1.2. So like
Correct.
4 balls we are just we are lagging.
Yeah.
So
So
that's what.
so it's both, right? So one challenge is, are we getting the data on time from the feed provider? But even if after you get it, getting that event and then doing the processing that I was talking about, and that, so that's something that we want to. So the feed provider we cannot fix, right? We have to be. I mean, it's a business decision, right? How much on what people are we relying on, and how reliable are they? What kind of business contracts do we have? And if something gets delayed, what is the hit, right? Like the worst case scenarios are scoring gets delayed. It's okay. So in majority of the feed providers that we are actually working with, send this data to a lot of very big players, so it's not that big of an issue. But we have the capability of completely doing it in-house if we need. So that's a backup. Now the other part, the lag, and so that's something where that that constant rewriting and constant improving of the system. So we one thing that we haven't been able to achieve so far, and that's our target for next IPL, is real-time leaderboard. Even today, so in a typical cricket game, to be very honest, even if you have a lag of a minute, because there's only one ball that mostly happens, right? But we want to build a system, especially for other sports, that as soon as an event happens, we want to update the leaderboard. That's our vision. It's not easy. There's like, especially at the scale that we have and giving the consistency that we want to give, but that's something that we actually want to build to solve exactly the kind of problem that you're saying and remove the lag completely from your experience.
Amit, you were talking about memoization and design patterns, right? So you gave an example that n requests will be clubbed together.
Correct.
On behalf of them, one of them will be contacting the backend servers, and the response will be like written to all the end users.
Yes.
I mean, end requests in fact.
Correct.
So, are you solving a thundering cut problem here? Is this a solution for thundering cut?
Yes. Kind of.
Okay. So in this case, like let's say like 1,000 requests are coming in, and you should have it should be asynchronous, right? If in this case, like it won't be synchronous, right? If you're doing it.
So the requests that are coming to the like the edge layer are synchronous, right? But so honestly, I don't know the implementation details of how it's actually implemented. I can like market it is right here. You can talk to him maybe after the chat, or I'll connect offline. I don't know the exact semantics of they've implemented it, but so one challenge obviously there comes in, how do we make sure that so the different servers are like holding on to requests, right? How do we make sure that the data again is consistent across everything? So that's where we actually have the downstream system send back a TTL, right, to everyone who actually.
Detail of the data.
Yes, of like when it does it expire. So the first server who goes will probably say that you have the data for 20 seconds, hypothetically. But a server which gets a request after 5 seconds would say only 15 seconds left. So that at the end of the day, when the TTL, when the cache invalidation happens, It should happen at the exact same moment for all the servers. You cannot have different servers serving data that is slightly different. Although this memoization is put for data that doesn't change that much, but still we added that capability because we built it as a framework, right? So we added that capability that in some cases it's possible that we'll use it for data that does change. So we wanted the downstream systems to be able to control that how much memoization, how long can you memoize it for, what kind of TTL you want, when should I invalidate, the power lies with the downstream system. And the upstream system is just purely dumb and doesn't understand the cache invalidation strategy.
So in this case, the round trip time, let's say if it is 5 seconds, so then all these end requests will be blocking, right? For
Talk
5
about
seconds.
milliseconds.
Okay. I'm just saying, like,
Yeah,
if it is like
no,
the
no,
round trip time is like,
absolutely. But for us, like our average, I think one thing that I should have put on our slide is like we serve 45 million RPM, but our average latency is 45 milliseconds for that. So we are talking about like thousands, and when we are talking about doing that, it's basically less than a second. Our throughput is so high that even if we cache it for like a few like 100 or 200 milliseconds, it drastically reduces the TPS basically. So that's why this problem doesn't happen for us, right? It's very short window.
alright, and you said you're using microservices, right?
Correct.
So right now in microservices, since because all these microservices are interconnected,
Yeah.
and it requires like extensive amount of monitoring that has to be incorporated. So right now, with respect to microservices, I guess observability is something that is going on and people are working on it.
Correct.
So have you adopted any sort of frameworks like Jagger tracing, Uber's Jagger, OpenZip, Zipkin?
Not yet. We did play around with some kind of request tracing at some point. I think we also looked at App Dynamics, I think it was, and there's some other tools available. We did some initial level of tracing as well. I think New Relic also gives you some capabilities of request tracing. If you just use New Relic across the system, it does that. But I would say that is not something that we have mastered. We want to do that. That's in our pipeline. We've played around with it a little bit, but I think, but with that monitoring of individual services itself and knowing like which services communicate, so far we've been able to get away with it. But definitely one of the things that we want to do is we want to build that end-to-end tracing, especially to debug, right? In case there are issues like exactly where the problem
Where
is.
the bottleneck is. So are you going to build it in-house or like you're going to adopt like
Don't know. So there is something. So our philosophy is like anything that's core to us or becomes too expensive to use some external, we build, right? So if, for tools like this, it doesn't make sense for us to invest our time in. So if a solution exists which actually serves all our use cases, I would, and is obviously reasonably not very expensive, I think I'll adopt it for sure. But if over time we realize that it's not happening, then we'll invest time and build it ourselves.
Okay, so another question. So when microservices communicate with each other, do you incorporate any sort of authorization mechanism for communication between the microservices itself?
Not today, right? So again, so security groups, we also identified like our security groups are way too open at some point of time, so we are like tightening that as well. But our authentication only happens at the user level for each user request. But once you enter our system, as of now at least, but again that will change, right? I mean, so there are a lot of security practice within our VPC itself where a lot of things are get controlled, so you can get away with it. You really don't. I mean, but as a good security practice, that's something on our radar, because so our security team also actually we started building a team around like a year back. So now a lot of security practice. First we started. It's again they have a priority list, right? So a lot of things, right? We even work with external providers like Bug Bounty and HackerRank, etc. So and tell them to actually try and then find vulnerabilities into our system. And so we did that. We are tightening a lot of things, but eventually we'll get to a point where we may introduce like authentication and authorization between services. As of now, we don't have it.
And for Cassandra, like you are using like C flavored instances, I guess.
Yeah,
Compute optimized.
correct.
Why not like storage optimized? The i3 instances.
So we did our bench, we did our test, right? As I said, for us it's a combination of read and write, right? So on surface, when you actually read the description, you're like, oh, this is a perfect fit. But the best way to decide is we actually launched a cluster of i3, we launched a cluster of C4, C4 2XL, C4 4XL, everything. We created load, we ran it, and we saw the one that actually gave us the best performance. We just moved to it. Now that's today, right? It's possible that over a period of time our workload may change, or maybe the instances become better. So we are constantly looking at it, right, all the time. But in our benchmarking, in our results, when we compared the instances, C family was performing better than the I family at that point of time. Yes, in fact, we started with M, I think, back in the day.